Alright guys, in this review lesson we're going to be talking about solving systems of equations using two different strategies. We have the elimination method, which you see here as number 1 and 2, the substitution method, which is numbers 3 and 4, and then we're going to extend those learning strategies to apply them to more complicated equations. So that's our objective, and let's go ahead and begin here with number 1. Alright, so we're going to begin by doing the elimination method. The elimination method works really well whenever you have your x's and y's lined up like that. What you're going to do with the elimination method is the first thing you do is you're going to pick a variable that you want to cancel out. So I'm going to go ahead and choose to cancel out the x's. Now what we're going to do is I'm going to multiply the top equation by the coefficient of the x on the bottom. So I'm going to multiply the top by 5, and I'm going to multiply the bottom equation by the coefficient of the x from the top equation, 3. And by doing that, I'm going to end up making those two x values in the front have the same value, because 5 times 3 is the same as 3 times 5, and they both equal 15. But you do have to multiply the entire equation when you do that, so make sure you do multiply the number all the way through. So that's what you would get if you multiply the top equation by 5. And if you multiply the bottom equation by 3, you would get this. So now notice that the x values that I wanted to cancel out now have the same coefficient because of that little strategy. The next thing I want to do is I want to make them opposite signs. So at this point what you're going to do is you're going to pick one of the equations and multiply it by a -1. And what that's going to do is it's going to make all the signs change. So now I have -15x plus 40y equals 5 for the top equation. The bottom equation will not be changing. All right, now that they've got the x values having the same coefficient but opposite signs, now we're going to add downwards. So if I add the two 15s together, they cancel because they're opposites. If I add the y values together, I end up getting, I think that would be 22y. And if I add the 5 and the 39, I get 44. And now we have a much simpler equation to solve. All I have to do now is divide by 22, and I can find out what y is. Now we're not quite done yet because we also need to solve for x. And the way you do that is just by picking one of your original equations, it doesn't matter which one, and plugging in the y value or x value, whichever one you found. In this case I found the y value, so I'm going to be plugging 2 in for the y value into the top equation. All right, and then from there you just go ahead and solve it. Just realized I made a boo-boo here. Let me back up a little bit. -1 plus 16 is not 17, it's 15. So x is 5. And y is 2. So my answers are x equals 5 and y equals 2. Alright, so let you guys try an elimination problem there on number 2. Now we'll look at another strategy for solving a system of equations, which is called the substitution method. You use this method anytime you have a variable that's by itself, like y equals or x equals. So as you guys can see here, I've got y equals. And what does y equal? Y equals this. Well, since y equals that, then I can replace y in the other equation with -3x plus 22. So I could just plug this in right there into that equation on the top. And then we just have to solve it after that. So we'll go ahead and distribute. Combine like terms. and we get -6. And if you want to solve for the other variable, then you're going to go back to the original equations. You could technically pick either one, but it is easier to pick the one where the variable's by itself usually. And we're going to replace the x with what we found out x equals -6. So that leaves me with 18 minus 22, which is -4. So now I've got my x value and my y value, and that's the substitution method for solving a system of equations. All right, so there's one for you guys, and we'll move on to the next part. So we've learned the two main strategies for solving a system now. We're going to move on to some more complicated types of equations. So I think for these types of problems, the best way to go about it is going to be to go ahead and do the, I think, well, you could do substitution or you could do elimination. I think substitution is going to make a little bit more sense here. So I'm going to go ahead and do substitution. Now, I can't do that, though, until I have a variable all by itself. So I need to get a variable by itself. And I think this is the easier equation to work with. So let's go ahead and get the, we'll get the x by itself. That'll actually be the easiest one. So I'm going to minus the y and minus the 2 on both sides of the equation here. And now I've got x equals -y minus 2. Now since I know that x is equal to -y minus 2, I could plug that into the x in the other equation up here, just like so. Okay, so if I do that, I'm going to have negative and then parentheses. Instead of x squared, we're going to have -y minus 2 squared because that's what x equals. Same thing with the next one here. Instead of x, we're going to have -y minus 2. And then the rest of the equation is going to stay the same because we're not plugging anything in for y. We're plugging things in for x. All right. So let's go ahead and simplify the expression here. Here I can FOIL this out. -y minus 2 times -y minus 2. I'm not going to show my work for this because we've already done this in a previous review lesson, but you would use the box method for that, just so you guys know. And this little negative in the front stays right where it is. So, but if we FOILed out the -y minus 2 squared, we would have y squared y plus 4y plus 4. Here we can just get rid of the parentheses. I think we don't really need those. Next, I would distribute this negative into the parentheses. At this point, I'm just solving, right? So the main strategy I want you guys to be aware of here so far is get a variable by itself and do substitution. All right, so now I've got -y squared minus 4y minus 4. That's if I distribute the negative. All right, and now we just go ahead and combine our like terms. There's the -y squared is going to stay the same, but this and this can go together as well as this. So -4 minus 1 minus 7. I believe that's -12y. And also, these numbers can go together. -4, -2, and -29. I believe that would be -35. All right. Now the way we're going to solve this, since it's a quadratic, is we're going to use the quadratic. I'm sorry, I'm not going to use. You could use the quadratic formula. I prefer factoring. So the first thing I do is I don't like negatives in the front. So whenever I have that, I'm just going to divide both sides by a -1. On the left side, everything becomes positive that was negative. And 0 divided by -1 is still 0. So that way we've got positives, we don't have to worry about the negatives. The next thing we do is use the box method to factor this. And that would be y plus 5 times y plus 7 equals 0. And then what we're going to do is we're going to set each one of those equal to 0 and solve. Now, we still have to find x. But what's interesting about this problem is that I found two different y values. So that means I'm going to also end up with two different x values. I'm going to have one x value for one of the values of y and another one for the other. So we're just going to pick an equation and plug it in. I'm pretty sure you're going to want to plug it into the one without any squares. That'll make life a lot easier. So let's do that. So for the, I'll break this up into two halves here. We're going to plug -5 in for the y first into this equation. So x minus 5 plus 2 equals 0. So we get x equals 3. So one of my answers is the pair 3, well, let me write it over here, 3 for the x and -5 for the y. Okay, now my other pair over here, we're going to do the same thing with the 7. So we're going to have for that one 5 for the x and -7 for the y. So since I got two y values, I have two x values. And the reason I got two y values is because we had a quadratic equation. So two different things about this problem. One thing is you have to get a variable by itself, so you could do substitution. The second thing that you're going to want to do on these problems is you're going to want to factor it to solve it, and you're going to get twice as many answers. All right? Let's go ahead and take a look at one more type of problem. Here's one for you to do, of course, but let's do one more. Now this time they're both ugly equations. And as I'm looking at this one, I'm noticing some things that are rather convenient. Like I'm noticing that these are exactly the same and these are exactly the same. And another cool thing about that is that they both have x's in them. So if I were to go with an elimination strategy, then I can cancel all the x's out at once. The problem is they're not going to cancel right now because they're not opposites. Like these are not opposites and these are not opposites. So I want to make them opposites. So what I'm going to do is I'm going to multiply the top equation by a -1. And that's going to change all the signs. That way, when I add downwards, the x's will cancel out. So now the top equation looks like this. Oops. The bottom equation is not changing. And now that these are opposites, if I add my two equations together, they should cancel out. So the 7's are going to go away here, the 28's are going to go away here. Adding these together, I get 7y squared. Adding these together, it's a big number. Let me use my calculator here. 63. And then adding these guys together, we get 56. Now, I could try factoring this to solve it, but it doesn't have to be that bad, honestly. I don't know if you guys noticed something special about the numbers 7, 63, and 56, but all of them can be divided by 7. So I'm going to divide both sides by 7, and that's going to make my numbers that I'm working with much smaller and therefore much easier to work with. All right, so there's that. Now we factor. Once again, that would be a box method problem. I'm not going to be showing my work on that, just because we've already reviewed that already in our review time. Previous lessons, if you want to see it, go back and watch how to factor. But in any event, I'm solving and I get y equals -1 and I get y equals -8. And this one, the last step is going to be similar but a little bit more complicated than the last one. It's similar in that we have two y values, and I have to plug each y value into one of my equations and solve for x. So I'm going to get two x values. The problem this time, though, is that none of these equations that I had to choose from are very nice equations, and both of them are going to end up giving me a lot of work to do. And, well, what can I say? You're in pre-calculus, these sorts of things happen. So I'm going to start with, I'm just going to use this equation, and I'm going to start by plugging in y equals negative 1. So I'll show my work over here on the left because I know I'm going to need some space for this. So if I were to plug in negative 1 for y, I just need to simplify this now. I've got 7x squared plus 7 plus 28x minus 108 plus 101. I can combine all of these together. Let's see, what would that be? Actually, they actually cancel each other out. Adding all those up, it's kind of convenient. And now I would solve this. Now, how would you solve this equation? That's not a box method problem. How would you factor that? That's a GCF problem. I could take a 7x out. So if I do 7x equals 0 and solve, I get x equals 0. And then if I do x plus 4 equals 0 and solve, I get x equals negative 4. So when y equals negative 1, I get two different values of x. I get 0 and negative 4. Now I have to do this whole thing again for the other y value that we got from our first step. This time I'm going to plug negative 8 into the top equation. Let's see what we get. Unfortunately, the number is going to be a little bit bigger this time, so I'll probably need my calculator. All right. So doing that there, I get 64 times 7 is 448. Yowzers. And this one's negative 864. Now if I put these three numbers together, let's see what we get. We have 448 minus 864 plus 101. And I get negative 315. Now something tells me that all of these numbers can be divided by 7. Why? Because that's how the problem's been going so far. And that's a huge number. So if I can, I want to try to reduce it. So I'm just going to try it, and I'm willing to bet you that this will divide by 7 well. I know that 7x squared divided by 7 works. I know that 28 divided by 7 works. Let's try that 315. Yep, it worked. It's 45. And so now I have much nicer numbers to work with there. And we can go ahead and factor that and solve it now. If you factor that, you end up getting x plus 9 and x minus 5. Set those equal to 0 and solve. X equals negative 9 and x equals 5. And so when I plugged in negative 8 for the y value, I got two answers for x, negative 9 and 5, which means that we actually have 4 different answers. Let me show you what those answers are. I've got this pair. When x equals 0, y is negative 1. I've also got this pair. When x equals when x equals negative 4, y equals negative 1. I've also got this pair. When x equals negative 9, y equals negative 8. And I've also got this pair. When x equals 5, y equals negative 8. So I've got 4 answers that satisfy that equation. So there's a lot going on there. But that'll do it for our systems of equations review with you guys today. Hopefully it's helpful, and we'll see you guys in class.